Hello, in today's video, I'd like to finish our discussion of control flow constructs that we have in Go by talking about defer, panic, and recovery. We'll start that discussion by talking about deferred functions, and how we can actually invoke a function, but delay its execution to some future point in time. Then we'll talk about how an application can panic. So in this conversation, we'll talk about how a Go application can enter a state where it can no longer continue to run, and how the Go runtime can trigger that, as well as how we can trigger that on our own. And then related to panicking, we'll talk about recovery. Now, when your application starts to panic, ideally you'd have some way to save the program so that it doesn't bail out completely. So we'll talk about if your application can be saved, how you can use the recover function in order to signal that to the rest of your application. Okay, so let's go ahead and get started. In a normal Go application, control flows from the top to the bottom of any function that we call. Now, of course, we can alter that a little bit by introducing branching logic so that we can skip some statements, and we can use looping that we talked about in the last video to repeat certain blocks of statements multiple times. But generally, a function is going to start at the first line and execute through until it gets to the last one. So if we run this program right here, we see that it's no big surprise that we print start, then we print middle, and then we print end. And what we can do if we want to defer the execution of one of these statements is precede it with the defer keyword. So if I put that in front of this print line here, then run that, you notice that middle is actually printed after end. So the way the defer keyword works in Go is that it actually executes any functions that are passed into it after the function finishes its final statement, but before it actually returns. So the way this main function is executing is it's calling line 8 and it's printing out start, then it recognizes that it has a deferred function to call, and then it prints out end, and then the main function exits. Now, when Go recognizes that that function exits, it looks to see if there are any deferred functions to call, and since we have one, it then goes ahead and calls that. So deferring doesn't move it to the end of the main function, it actually moves it after the main function, but before the main function returns. Now, if we put the defer keyword in front of all of these statements, then we'll actually see an interesting behavior, because the deferred functions are actually executed in what's called LIFO order, or last in, first out. So the last function that gets deferred is actually going to be the first one that gets called. And this makes sense because often we're going to use the deferred keyword to close out resources. And it makes sense that we close resources out in the opposite order that we open them, because one resource might actually be dependent upon another one. So if we run this like this, we actually see that we've reversed the order of printing this. So we're now printing end, middle, and start. And just to remind you, these aren't executing in the context of the main function. They're executing after the main function is done, but before it returns any results to the calling function. Now, these are good theoretical examples, but in this situation, I felt it makes sense to get a little bit more practical example for you to look at. So for this, we're actually going to need to go into Visual Studio Code, because we're going to need to run a program that's going to make some resource requests through the HTTP package, and you can't do that in the playground. So if we look at this program here, we're importing a couple of packages, then we're using the get function from the HTTP package in order to request the robots.txt file from google.com. Now, this example you can actually find in Go's documentation. I basically stole this as an example for how you can use the deferred function. Now, as you can see with this request, we're going to get a response and an optional error, and we're going to check to see if that error is nil, and if it's not, then we're going to log that out and exit our application. If it is not nil, then we got a good response. So then we're going to use the readAll function from the IOUtil package. What that'll do is that'll take in a stream, and that'll parse that out to a string of bytes for you to work with. So if we look at the robots variable here, we see that that is a string of bytes. And then we close the body of the response to let the web request know that we're done working with it so it can free up those resources. Of course, the read operation can fail, so we're checking for that error. And then we're finally going to print out the value of the robots variable here. So if we run this application by invoking it with the go run command, we see in fact that we do get the robots printed out, and everything worked out just fine. So we got this entire response printed out to the console here. Now, one thing that we're doing here that the defer keyword can help with is handling this body close. Now, in this application, we only have one statement that's really being worked with between the request being made and the body being closed. However, in many applications, you might have quite a bit of logic that's involved that needs that body to be open and continue to work with it. Maybe you're reading the stream one character at a time, and you're doing some pattern matching or something like that. So you can actually end up with quite a few statements in here. So what can happen here is that you might make this request and open up this resource up here, and then it might be dozens of lines later that you actually get around to closing it. Well, that introduces the possibility that you forget to close it. Now, it's going to be hard to find that, and it's going to be hard to remember to close the resource, and so you're introducing the possibility of bugs coming into your application. So what we can do is add the defer keyword here, and then we can go ahead and move this up a line. So if we run this, then it looks like we're closing the resource and then we're trying to read it. But if we run the application, we see that it works just fine. Everything comes out the same way it did before. Now, if we leave the defer keyword off, then we do get an error because we closed the response body before we were done reading it. So what this allows you to do, and this is the most common use case that I've seen for using defer, is it allows you to associate the opening of a resource and the closing of the resource right next to each other. So you see this pattern a lot, where we're going to open a resource, we're going to check for an error, and then we're going to close the resource. Now you want to check for the error first, because if there's an error generated here, then you actually never got this resource, and so trying to close it will cause your application to fail. But as long as you know that you have the resource there, then it makes sense to do a deferred call to close it. Now, one thing I would warn you about is this is a pretty common pattern, and you're going to see this all the time, but if you're making a lot of requests and opening a lot of resources within a loop, then using the defer keyword to close it might not be your best choice. Because remember, the deferred statements don't execute until the function itself executes. So if you've got a loop that's going to loop over 1 million resources, you're going to have 1 million resources open before all of those get closed at the same time when the function finally executes. So if you're working with resources in a loop, then you might not actually want to use the defer keyword. You might want to explicitly close those resources when you're done with them. Or another option would be to delegate the processing of those resources out to another function and have that function close the resource. That way you're not keeping a bunch of resources open at one time and wasting memory. Now the next thing that I want to show you, we can do back in the playground. So I want to do that because I think that's the most accessible environment that we have, is this program here. So when I run this program here, what do you think is going to print out when I run this? Now there's 2 lines of thought that you might have. The first line of thought is, well, I'm defining A as the string start, and so I'm going to print start out, but you might also realize the defer statement is going to cause this statement to print after the main function is done, and before main is done, we've already changed the value to end. So you could make an argument that this is going to print start or end. Well, the fact is that we're going to get the value start printed out. And the reason for that is when you defer a function like this, it actually takes the arguments at the time the defer is called, not at the time the called function is executed. So even though the value of A is changed before we leave the main function, we are going to actually eagerly evaluate this variable, and so the value start is going to be put in here. We're not going to pay attention to this value as it changes. Now the next thing that I want to talk to you about in this video is what's called panicking. Now in Go, we don't have exceptions like a lot of applications have, because a lot of cases that are considered exceptional in a lot of languages are considered normal in a Go application. For example, if you try and open a file and that file doesn't exist, that's actually a pretty normal response. It is reasonable to assume that you might try and open a file that doesn't exist, and so we return error values, we don't throw exceptions because that's not considered exceptional in Go. However, there are some things that get a Go application into a situation where it cannot continue, and that is considered exceptional. But instead of using the word exception, which has a lot of connotations because of its use in other languages, we're going to use another word, and that word is going to be panic, and that's because our application can't continue to function, and so it's really starting to panic because it can't figure out what to do. So if we take this example here, I'm declaring 2 variables, A and B, and setting A equal to 1 and B equal to 0. Now obviously, the answer of 1 divided by 0 is invalid. We can't do that in a Go application. So if I run this, we're actually going to see that the runtime itself will generate a panic for us. And the runtime error is printed out, integer divide by 0, and then we get a stack trace letting us know where that error occurred. Now if you're going along and writing your own program, and you get to a situation where your program cannot continue to execute because of a certain state that gets thrown, then it makes sense for you to panic as well. So to do that, you're going to use the built-in panic function like we see here. So we're printing out start, then we're using the built-in panic function, passing in a string, and then we're going to print out end. Now what's going to happen when we run this is very similar behavior to when we had that divide by 0 error a few seconds ago, but the error message that's printed out is actually going to be the string that we passed into the panic function. And then notice we get the same stack trace out. We do get start printed out, but of course we don't get the string end printed out. Now, a more practical example, now this will not run in the playground, but that's okay because it probably wouldn't fail in the playground anyway, is this one here. So this is a very simple web application where you're going to use the handle funcs. So we're registering a function listener that's going to listen on every URL in our application. And then this is a callback that gets called every time a URL comes in that matches this route. And all this is going to do is print out the string hello go. As a matter of fact, why don't I go ahead and do this over in Visual Studio Code, that way you can see what this program is going to do. So we'll go ahead and save this and we'll get it up and running. Now there's no errors, it went ahead and started okay. So if I come in and hit that URL, which is at localhost 8080, then you see that we get the string hello go printed out. There you go, an entire web development course in one video. So we've got a very basic web handler that's printing out the string hello go, and that's coming from this line right here where we're writing to this response writer. This response writer is basically giving us access to the response to this web request, and we're printing out the string hello go. Now, what's interesting here is this error handler right here. So the listen and serve function returns an optional error object. So when might that happen? Well, one situation that can happen all the time when you're firing up a web server is the port could be blocked. So if I open up another terminal here and go ahead and try and run this again, you see that we get our application panicking. And the reason for that is we're trying to access a TCP port that's already been blocked. And it's been blocked by the fact that we're running the application over here. So this is a situation that happens all the time. Now, the listen and serve function doesn't have an opinion on if that's a panicking situation or not, because it just tried to execute something and it's going to return an error value saying, well, that didn't work. It's reasonable to assume that listen and serve can fail. And so it's not going to panic, it's going to return an error. Now, we're the ones writing the web application, and we know that if that doesn't work, the entire application gets brought down and nothing happens. So in that situation, we decide that we're going to panic, passing out that error that comes from the listen and serve method, letting whoever's trying to start this up know that something very bad just happened. So this is a common pattern that you're going to see in Go. Go is rarely going to set an opinion about whether an error is something that should be panicked over or not. All it's going to do is tell you, hey, this didn't work the way that you expected it to work. It's up to you as the developer to decide whether that's a problem or not. So in this case, we say, yeah, that is a problem. We failed to start our application. And so we do want to generate a panic. So what are we going to do in the situation that our application is panicking? And we can get ourselves to a situation where we can recover the application. So panics don't have to be fatal. They just are if we panic all the way up to the Go runtime and the Go runtime realizes, well, it doesn't know what to do with a panicking application, and so it's going to kill it. So we come back to this application here and run. We see that once again we're getting this panic. But something I want to show you related to our deferred discussion is this modification here. So I've added this line, a deferred print statement that says this was deferred. So if we run this application, something interesting is going to happen. We get start printed out, that's not a big surprise, but then we get this was deferred printing out, and then the panic happens. And this is really important because panics happen after deferred statements are executed. So the order of execution is we're going to execute our main function, then we're going to execute any deferred statements, then we're going to handle any panics that occur, and then we're going to handle the return value. So there's actually quite a bit that happens in a function after it exits this closing curly brace here. So why is this important? Well, the first thing that's important is that deferred statements that are going to close resources are going to succeed even if your application panics. So if somewhere up the call stack you recover from the panic, you don't have to worry about these resources being left out there and left open. So any deferred calls to close resources are still going to work even if a function panics. But the other thing that's really important is if I change my deferred function here to something like this. Now this is a custom function and we're not going to talk about this for a couple of videos yet, but this is important in order to talk about this, so I need to jump this ahead in the queue a little bit. So what we're creating here is what's called an anonymous function, and an anonymous function is simply a function that doesn't have a name, so nothing else can call this. This is defined at one point and we can call it exactly one time. These parentheses here are making that function execute. And this is an important thing to know about the defer statement. The defer statement doesn't take a function itself, it actually takes a function call. So you want to invoke that function, otherwise things aren't going to work properly. Now inside of this custom function, notice that we're using this recover function here. So what the recover function is going to do is it will return nil if the application isn't panicking. But if it isn't nil, then it's going to return the error that actually is causing the application to panic. So in this logical test, we're checking to see if it's not nil. So if it's not nil, that means our application is panicking. And in this situation, we're simply going to log that error out. Now what happens in this situation is the execution still stops at the panic. And let me import this log package before we run this. And we see that the application still executes. So we got the string start printed out. Then we printed out the error using the log package, but we didn't get this end function printed out. So it looks like our application is still dead, but recover does have some important impacts if we have a deeper call stack than what we're dealing with right here. So let me drop in this example in order to show you. So in this case, we got the main function that's going to be our application entry point, of course. And then we've got this other function called Panicker. And all this thing does is it's going to print out a line that says it's about to panic, and then it's going to panic, and it's going to go ahead and recover from that panic using that deferred function that we saw just a moment ago. Then we're going to have this line here, done panicking. And then up in our main function, we're going to print start, we're going to call the panicker, and then we're going to print end. So let's see what happens when we run this. So as you see, we get the start line printed out like you would expect. We see the about to panic string print out. Then we panic, something bad happened. We go into our recover loop because we're not going to execute this because our application panicked, and so our panicker function is going to stop execution right there and execute any deferred functions. And inside of that deferred function we call recover. So in that recover, we're going to log out the fact that we have that error, and we're going to log that error message out that we see here. But then in the main function, execution continues. So in the event that you're recovering from a panic, the function that actually recovers still stops execution because it's in a state where it can no longer reliably continue to function, and so it makes sense for it to stop doing whatever it was trying to do. However, functions higher up the call stack, those functions that called the function that recovered from the panic, they are still presumably in a situation where they can continue because your recover function said that your application is in a state where it can continue to execute. Now this is a little bit limiting as well, because in order to determine what that error is, you actually have to call the recover function, which basically means that you're saying that you're going to deal with it. So what happens if you get that error and you realize that this isn't something that you can deal with? Well, in that case, what you're going to do is repanic the application. So all we need to do in order to do that is just rethrow the error, or you can come up with another error string, whatever makes sense for you. But in this case, inside of the handler, we're throwing a panic again. Then we actually see that we don't get that end statement printed out. Our main function panics because we rethrew that panic. So we get the full stack trace of when the panic actually happened, and we see that we're inside of func1. Func1 is actually this anonymous function right here, and we see that we do get that stack trace printed out, and we don't get the string end printed out. So if you're in a situation where you're trying to recover from a panic and you realize you can't handle it, you can feel free to rethrow that panic and defer the management of that panic higher up the call stack. Okay, so let's go into a summary and review what we've talked about in this video. In this video, we talked about the final two control flow concepts that we have to be aware of in Go programming. Now, one could argue that defers and panics aren't really control flow constructs because they're not the traditional branching or looping logic that we consider, but they definitely do alter the flow of execution of our program, and so I'm going to lump them together in this category. The first thing that we talked about was the use of the defer function in order to delay the execution of a statement until the end of a function. Now these are useful to group open and close functions together. So if your open function is going to open up a resource and you need to make sure that you close that, then you can defer the call to close that resource to make sure that you're freeing up the memory and not holding onto that resource any longer than you need to. The one thing I would warn you though is be careful in loops. If you're opening and closing a bunch of resources inside of a loop, then you probably want to explicitly handle that close without the deferred keyword, because when you're using the deferred keyword, all of those resources are going to stay open until the function finishes execution, and that can cause you some memory issues, especially if you're dealing with a very large number of resources. Now, if you've got multiple deferred statements inside of a function, then they run in LIFO order, or last in, first out. So the last deferred statement that you call is going to be the first one that actually executes. And again, this makes sense because if you're opening a bunch of resources and those resources are dependent upon one another, then you're going to close them in the reverse order that you open them, which is typically the right way to go. Arguments in a deferred call are evaluated at the time the defer is executed, not at the time the called function is executed. Now that's important to keep in mind because you could pass in variables into a deferred function call, and it can be a little bit confusing if you change the value of those variables further on and those aren't reflected in your deferred statement. So just keep in mind, when you call defer, the value of those variables are going to be captured at the time that that defer is executed, not at the time the function actually executes. Now, something unplanned happens in our application, then we've got two ways that a Go application can go. It can return an error value, which is the normal case, or it can panic. Now, what you generally want to do is you want to return an error value, because in Go programming, we typically don't consider a lot of things that go wrong in an application to be exceptional events, or to be events that should cause the application to shut down, for example. A classic example of that is making an HTTP request, and you make the request and you don't get a response from that server. Well, that's something that happens all the time. No response is a valid response. It just happens to be an error because you're looking for that resource and you got a 404 return back. So in that case, you're going to return an error value. You're not going to panic the application. Panics are used when an application gets into a state that it cannot recover from. For example, if you hand the runtime a divide by zero problem, there's no way for Go to figure out how to divide a number by zero, and so it has no way to manage that. And that's a situation where the application is going to panic. So just to summarize that, they occur when an application can't continue at all. Don't use them when a file can't be opened, unless it's a critical file. For example, if you're opening a template that's used in a web application to generate your view layer, then that might be something that's worth panicking over. But if you're trying to open up a log file and you can't get there, well, there's no reason to panic for that necessarily. You just need to return an error value and then inform somebody that the logs aren't available. Now, a situation where you might want to panic is unrecoverable events. So if you're starting up a web server and it can't get a hold of the TCP port that it's supposed to be listening on, then that's probably a situation where a panic makes sense. The function will stop executing immediately at the point of the panic, but deferred functions will still fire. If nothing handles that panic, then eventually the panic is going to go up the call stack, it's going to hit the Go runtime. The Go runtime has no built-in handling for panicking situations, and so the program will then exit. If you do have a panicking situation that you feel that you can recover from, then you can recover using the built-in recover function. Now, that function is used to recover from panics. It's only useful inside of deferred functions, and the reason for that is because of the behavior of panic. Remember, when an application starts to panic, it no longer executes the rest of that function, but it will execute deferred functions. So the proper place to use the recover keyword is inside of a deferred function that's going to look for a panicking situation, and if the application is panicking, then it can go ahead and decide what to do with it. The current function will not attempt to continue, but if you do recover, then higher functions in the call stack will continue as if nothing went wrong. Now, if that's not the behavior that you want, if you call that recover function, you look at the error that's returned from the recover function and you can't handle it, remember that you can go ahead and rethrow that panic by calling the panic function again, and then the panic will continue to propagate up the call stack. Okay, well that finishes up our discussion of the control flow concepts in Go. I hope that this was useful for you. As always, if you have any questions or comments, please feel free to leave those down below, and I'll come back soon with another video introducing the Go language. Take care.